All right, hello biology students. I wanted to take a minute and show you a little bit of the work that you're going to be doing today. Unless that watch this at some weird time, but that you should be working on today. And it has to do with a little bit of math. And I think that you guys could probably puzzle out how to do this on your own, but I want to sort of give you a little reference. I'm going to put up a really cool video for you that shows scientists using this kind of quadrat sampling technique to find different creatures. Now, this is usually used for sessile, non-moving, sedentary creatures. And the way it works is you measure out a length. Sometimes people put poles and stuff, like if they go through a forest, they might have a little setup that they can just pop in around. And what they do is count how many creatures or trees, coral species are in that little rectangular or square area that they call a quadrat. That's called quadrat sampling. There's many different ways that ecologists sample creatures. I mean, that's how we get a count and know how many trees are in this area. If they say, okay, well, we estimate there's 500 tigers, Bengal tigers left in the wild. Well, how do they get that information? How do they know how much is there? Well, one way scientists sample these things are through quadrats. And again, this is better for non-moving things because you can know the area you're sampling. You can come back 3-4 months later, a year later, and sample that same area and see is there a change, an increase, decrease, who increased and who decreased, and what's there now. When I was in school, we studied plants, and my advisor would like to pipe in with a lot of good things, and one of them was about plants. If you're sampling them, you don't have to worry because they don't really get up and move. So we kind of knew we were sampling pretty much the same plants for the whole year. So here in this little paragraph, they're giving you a lot of information. We're just going to look at the math information right now. And so they're telling us each of these square quadrats are 1.5 meters by 1.5 meters. And then they tell us they conducted an 18-meter squared transect. That means they went like sort of across for 18 meters squared. So that's the total area of what they sampled. Is that the total area of one quadrat? No. How do I find area of a square? Well, it's side times side. Okay. So each one of these squares is 2.25 meters squared in area. If you look on the outside, this is just sort of like a length, a measurement. It's not meters squared, it's meters. So the area inside is 2.25 meters squared, and I got that by multiplying these two numbers. Remember, area of a square is side times side. So they measured over 18 meters squared, so they used several of these. So they measured and counted several times. So they said, how many quadrats do we need to look through 18 meters squared? Well, you need to get the area of 1. And I told you that's 2.25 meters squared. And I told you I got that by multiplying side times side. Then all you have to do is divide those two numbers. You'll end up with a whole number. And that will give you how many quadrats they used to sample that whole area across. How many square meters does the crystal coral cover in this experimental sample? Well, it's telling us it's 10%. So you multiply 10% by the total area, and that number will give you the area covered just by crystal coral. Easy. If the percent stays the same, okay, well then, so you have to figure out using this number. Okay, so you find a number in this one, it's 10% times your area. Then you get a number. Okay, we'll multiply that number times 100 meters squared. That's, how much coverage you would expect in the area. Okay. What percent of the entire reef? Well, they measured 18 meters squared, and the total is 360. So to get a percent, you have to divide those two numbers, okay, and multiply by 100. So make sure you're putting your numbers in right, because if you get something like over 100%, then you put the numbers in backwards. You should get like a decimal number. So 18 meters squared divided by this, the total, that'll give you a decimal. You have to multiply by 100. So hopefully that helped you kind of walk through these. Yep, those are the math questions. I just wanted to walk you through the math questions because we kind of did this in a different order, and we, since we're all online, we haven't really been able to do the lab of Quadrat sampling, which is a lot of fun, but it's not something that we can do at home, sadly, or I haven't been able to figure out how to make it virtual. If I do, we can always come back and do it, but when we would have done that virtual lab, we would have done more with this math. So I wanted to take time now to just tell you how to do it and walk you through really simple. But I'm going to leave you with a video about Quadrat sampling and how you can use that for things that move, but this is a very large scale operation that they do. It's really interesting. And why do you want to sample? Well, remember, biodiversity is very important for the health of the ecosystem. The more different creatures you have, the healthier the ecosystem. And we learned about these creatures, that there are all these different creatures that can be a keystone species in an ecosystem. And if that's the case, then it's going to have wide-reaching effects on the rest of the ecosystem if that creature is gone, like the coral, or maybe like elephants or wolves. So we need to keep it an accurate count. It's not going to be perfect. We need to get an accurate sample and an accurate count of the creatures that live in an area so we can kind of determine the health of the ecosystem. So if I'm a scientist and I want to say this company over here is adding something to the water that's hurting this coral, for example, I need data to be able to back that up. And so how am I going to get my data? By sampling and seeing the change over time. So sampling is an important part. It has to be done accurately as possible. And we would have done, like I said, a sampling lab if we had been here. And if we do come back anytime soon, when you come back, we'll do the sampling lab. All right, well, I hope that helped you with those math questions. You can always message me and ask if you're struggling. Like I said, I don't want to just give you the answer, but I want to make sure you have an idea of how to set it up. All right, hope to help. Bye.